So, hello. Kdo tady rozumíte česky? Aha. A chtěli byste tu přednášku v češtině? To je málo, tak let's do it in English. I'll try, okay? Sorry for that. So, okay. So, React Compiler, the game changer. This is the talk and the title. And this is my second time here in a row. Maybe you saw me last year here about Next.js. So I'm happy to be here again and to see you again. And I hope the clicker will work. Okay, so a few words about me. Currently, I'm on parental leave, but I've been working in Heureka more than 4 years. And actually, and currently, I'm a team leader of a Road to Product team. Also, I'm front-end leader of the front-end group guild in our company. And also, I'm the React lover. I've been using React more than 10 years, and this is my, heartbeat thing, Also, I've been taking courses and teaching React on private courses or public courses, or recording the video courses about React and so on. So, okay. Let's move. So let's try the React compiler. Free? Great. And what does work with React in your job and as a hobby? Okay. Great. And who does write code in JavaScript or TypeScript here? Okay, so majority of you. So, but still, we have to take a small warm-up about comparing values, because, why do we need about it? Because it's JavaScript, yeah, and it's tricky. And maybe it wouldn't be anything new for you, but let's recap the comparing values in React or in JavaScript. So React is, there are examples from comparison in React. So React uses Object-is API for comparing values, and primitives work as usual in that case, like numbers, booleans, and strings. Yeah, but there are issues with object data types, because they are stored somewhere in the heap of memory, and there are pointers from the stack on that, and that keep the references. And the comparison is based on the references on the memory. So if you compare two same objects, or objects with the same values, in that case, two empty objects, the result is false, and the same with array, and with two seamless functions. So nothing new for you, yeah? Am I right? You know about that? Great. So we have to solve that issues about referencing and memory and objects and object data types like this way in React. So we usually memoize the object data types by use memo hook to memoize the reference, yeah? And when we use that objects as a dependencies, for example, in some hooks like use effects and so on, so for correct behavior, we have to memoize them, yeah? To ensure that the React will somehow could recognize that it is stable during the renders, yeah? Okay. The same issue is here when we pass the object data types as a props to the component, like here, these child memoized components wrapped by React memo consumes update value function. It's a function, so object data type again, and it is triggered based on the calling or clicking on the button, yeah, here on the click prop. And it is a parent component in that case, and usually we have to memoize this a function for updating state with use callback hook, yeah, to ensure that the child component wouldn't be rendered anymore if it's not needed, yeah? Again, comparing the references. So I'm speaking about that because with the compiler, we will not need it anymore in the future. So it's great news, yeah? So what is the compiler? High level, yeah, just high level. There are a few steps. First one is lexical analyzer. It's tokenizes the source code and generates the tokens somewhere. Then comes syntax analyzer that creates AST, abstract syntax tree from it to structure to source code tokens logically, yeah, logically. It's important. There comes semantic analyzer that validates that code, even semantics or syntactics, yeah? And based on that, it's generated some ER code, intermediate code. Maybe you know that, like ER code. Then comes optimizations based on that ER code. And finally, the machine code is generated by that one, by the last step, yeah, on the optimized code. So, yeah, high level, yeah. Compiler is some kind of program, yeah. So we are speaking about React compiler. And what is important that it's not React 19, yeah? React compiler is standalone, it's not React 19, and it's still in development right now. Maybe you can know the React compiler as React Forget, the code name, but they change it to React compiler. So currently, there is a beta release, so I think, yeah, they released that on 21st of October, so 11 days ago, as a beta release or a beta version. So it's public, and there you can see there on the bottom this is a roadmap, and still there are at least two stages to make it stable in the future. And I think it will take a few months at least, yeah. So but now it's public beta, yeah. And this is our time. What are the goals of the React compiler? To bound the amount of rendering on updates or components. Yeah, definitely. And keep the startup or mount time neutral. Don't touch it. Yeah, it will increase the bundle size, definitely, but without impact to the startup time. The goal also is remove manual memoization concepts, yeah? Like use memo, use callback, and React memo. And just work on idiomatic React code that follows rules of React and React hooks, for example. And just focus on the business logic and write the code, just the business code, not the stuff around to, work it properly. And it should lead to increase the productivity of developers, definitely. So there are three main components of React compiler. The first one is Babel plugin, the second one is ESLint, and the last one is compiler core, not the monkey. So how to integrate? The first thing you have to do, or we have to do, before integration is to run the health check of your code base if it is compatible with the compiler. You can write by this command, and it will print it out, something like that, to the console. Like it will try to compile all of your components in your code base, check the strict mode usage, and try to find incompatible libraries like Mobix, for example. It will look fine, in that case. And this is the integration, very easy. Just install the Babel plugin and just, register it as a plugin to your Babel config. Also, you can do it in Vite, Remix, Next.js, Expo, EarsBuild, and Webpack. But Webpack, I have tried Webpack too, but it's not working properly, yeah, still. But who does use backpack here? Okay, only one. Okay, great. So we can opt in the compiler to just few components. Otherwise, it will be by default, available for your all components in your code base. Yeah, they will be automatically compiled. So you can opt in just a few components of your namespaces of your some directories by this config with definition of secure sources. Or you can turn on the compilation mode like annotations, and you can just sign your components with use memo directive directly. Yeah, and just only this component or these components will be compiled by compiler. Also, you can opt out the compiler with this directive. Use no memo. Magic, okay. Great. And then you can install ESLint. Yeah, it's great. It's a great tool. And this plugin to ESLint will be the part of the main package ESLint plugin React hooks in the future. But now it's separated, standalone. So you have to install it this way and ensure that rules are set as errors from the React compiler. And in the DevTools, in the version later than 5, you can see that some components in your tree could be auto-memoized and signed by this badge or labeled by this badge like Memo Magic. Yeah, and this is the compiler's output. So yeah, still it is very important to write compatible code with the compiler to allow the compiler to compile your components. So we have to still follow the rules of React, like immutability, idempotency of functions, purity, and not calling React hooks in different, conditional calling and calling it on top level of your functions and so on. Still, we have to follow the rules of React. It's important. So let's see React compiler in the action. Here is the QR code to my repo that is prepared for this purposes, for this demo. So then you can download it, but I will show you a small, it's not live coding, but showing the examples. Okay. Is it visible for you? Even upstairs there, yeah? Okay. So here though, this is the basic stuff and basic stack. It's too large maybe. Okay, this is the Vite application with installed React compiler, yeah, and with React 19 in the release candidates, yeah, in the latest version. So it's React 19, not 18, but 19. So yeah, super hot. And I prepared a few examples for you to explain, how does it work, yeah? Okay, examples. So first component here, it's called with data, but there are static data, so sorry for that, but, very, simple component here, just nested elements inside and define constant or variable as a constant here, string John Doe. And here's the preview. Yeah, it works. And I'll show you also the DevTools. So this component has been auto-memoized by React compiler. Great. What does it mean? So I will show you my playground. Okay, so maybe it is too large. So in the left-hand side, this is the Babel transpiler. So this is the JSX, and it is transpiled to JS code by Babel to something like that. Some nested JSX elements with props and so on. Nothing special. And sorry for that, because This is the React compiler playground, yeah, and they didn't, introduce some kind of dark mode. So sorry for that. It is just light mode, but this is the official React compiler playground, and this is the source code of the component, and here, we can see the output. So maybe I will, yeah, great. So this is some kind of anonymous function, and there is calling something like _c with parameter 1. What? Okay, what is the C function or C hook? So this is exactly something like that. This is the memoize function. It's called use memo cache hook, and this is the implementation. So this is a function that accepts, the size parameter, and it will create the array, the memoized array, by use memo, and it will fill all of the items, just reserve a spot in the memory with some symbol, with symbol React Memo Cache Sentinel. So it is memoized reference to the array, not the content, yeah? Not the content of array, but the reference. There is not used something like use state and set method, because otherwise it could, but it will trigger the renders, yeah, of the component. So in that case, we just mutating the memoized object, like array in that case, and don't triggering the renders, or not triggering the renders of the components. And the output could be like this. So calling C with parameter 2 will create 2 slots in the memory with the symbols for the future, for the usage in the compiler. So this is exactly this. So it will create the array with 1 slot, yeah, in the memory. Then it will create the new variable, the let, and then just check whether this part of code is in cache. Yeah, this div with P and strong and John Doe directly, you can see that there is not created the variable name, but it will apply it directly, so it's smart. It's smarter than other compilers in the front-end world. So if it's not cached, it will be added to the cache. Otherwise, in another round of rendering of the component, it will just take it from the cache, yeah? And just return T0. As a proof, I hacked React compiler, and I can show you the console log with the cached object, and exactly there is some hash, and there is the object itself, so you can see there is some div, and there are some other child, or the other children, and there are 2, yeah, P and strong inside. So yeah, this is the output in a React DOM client. So do you understand how does it work? The compiler, so how use cache memo or use memo cache function works? I hope so. So we will go forward with another examples. So this one was very simple. Second one, small demonstration of usage, use memo, yeah, and use state. So this is just counter that just increments, twice, doubled the input. Here though, again, auto-memorize component by compiler, great, and more important here is the output from the compiler and Babel. So in Babel, you can see there is called use memo, yeah, memoizing the updater function here for setting state and doubled byte count. and it is called, or it is revalidated only when count has changed, yeah? And here's the compiled code and compiled output. Wow, it will create 7 slots in the memory for this small component. You can see there's use state calling, yeah, it's great, but there is no use memo. How? Because it's not used, it's not used there. It's already cached by React compiler, and it will omit the manual memoization if it's not needed for that. So great, it's clever. So let's just map it again. It will create T3 variable and just return it. And what is the T3? T3 is something here. Yeah, this is just div and T1 and T2 inside. What is T2? And you know, there is if, yeah, there's condition whether the T1 or T2 has changed. If yes, it is recalculated again. But T2 is just the button with on-click handler with set count from the use state, and it's recalculated again or revalidated again when the count has changed. And T1 is nothing else than just this paragraph with the count printed out. Also, again, revalidated when the double count has changed. Cool. Another example. Sorted list memoized. This is just component that accepts the names array as a prop, and it just called or sort the inputs, you know, alphabetically. Also, again, use memo there. Here is the output. Just sort. It has sorted the array. You can see here that it's not auto-memoized. How come? Because of this. Okay, I have to copy it again. Great. So, wow, cannot preserve memoization. So, React compiler cannot compile this component. It has skipped that optimization and compilation because there is existing manual memoization that could not be preserved because it could lead to, you know, bad behavior of the component. So it just, you know, omitted for that case. It's not compiled, and it's the fallback. The original solution in the React runtime is used for that time, yeah? And it's run as usual and used as usual. So it could not be compiled because it couldn't be preserved in that case. Okay, again, there is a sorted list. The same without use memo. The same code, just iterate the array and just print out the items with keys and name, nothing special. And here's the output, auto-memoized and compiled code is here. So there are 4 items in the memory as a slot. By calling C function, it is consuming the names as a props or from props and create T1 whether names has changed, you know, and just called names, you know, the toSorted method on that array and map it to something temporary. What is temp? It's great. It will create automatically the new memoized component with the item temp and use it for the map function or map method, sorry. So yeah, it's cool. And the component itself returns T2 variable. And what is it? It's the list with T1 inside, again created here, and T1 is just auto-memoized sorted map, sorted names with the mapping on the temporary component and memoized until the names has changed. You know, it's great. It's clever. Cool. Another example, use effect. Yeah, maybe it's a great question. Will it solve the dependencies in the use effects and other hooks? Do we need, or will we need to put them as a dependency still in the future with the compiler? Unfortunately, we have to, and we will have to. But it will again, solve the issues with the memoizing to the functions and object data types as a dependencies. So yeah, it will be better, but still, we need the dependencies arrays. So this is just timer, sorry. This component, and you can see it's auto-memoized, and every second it will update the state and print it out like a timer. Nothing rocket science, yeah? It's auto-memoized, and we know that use effect inside, can I make it, okay, whatever. Use effect inside is calling in the setup function, the console log and some set interval with the adjust time function that is passed as a dependencies to the array and to use effect in the array depths. And here is the just small implementation for the time update in the state. But what? There is ESLint bug because we know we don't have to use callback anymore with the React compiler, but still ESLint, is crying that needs to be auto-memoized by use callback, or no, manually memoized by use callback. Yeah, because here it's used. So this is the first bug I discovered with usage of React compiler or ESLint compiler plugin. Because the old way was wrapping that with the use callback without the compiler. I will bypass the auto-memoization, and yeah, you can see it's not auto-memoized anymore and works the same, but with use callback, so manual memoization. So we don't have to do it with React compiler anymore. It's great. And I'll show you the compiled code and the output of the compiler. Great. Okay, use no memo, but it will create again 5 slots in the memory and go from bottom. Returns T3 variable, and T3 variable here, it's again this tree, div, nested div with time, to print it out the current state, the current time, and just recalculate it again when time has changed. And here, though, it's calling use effect with T1 and T2 as dependencies, as parameters. So what is T1? T1 here, again, it's the setup function of the use effect. Auto-memoized, great. And T2, it's the dependency of the use effect, the array depth, yeah? Adjust time, and adjust time here, though, is T0, and again, it's handled by the cache mechanism again. Just anonymous function that is, created only once and added to cache and used. Great. So, speaking about the bugs and ESLint, I will show you a small example or few examples of the new ESLint plugin, React compiler. So, for example, the new one will catch this kind of issues like accessing to current on your references during the rendering the component, so inside the render part. Similar situation is with the state and mutation the state, so we cannot directly mutate the state, we have to use the set function, yeah? Or from the use state hook. So yeah, it will cry again. Similar with demutating of props, we cannot do it we cannot mutate the props. They are just read-only for you. So it will catch it again. Similar situation with reassigning the const. It's cached by React compiler ESLint plugin also. And here though, it's performing side effects. So you can see here that I tried, or I do it here, just mutate the variable defined outside the scope to add there, increased it by 1. So here though, we can remove this use no memo, and the ESLint will still work for that case. So it's great. And in the previous example here though, I forgot. So if we preserve or bypass some kind of React rules, ESLint rules like this one, if I bypass it, it will lead to skip the optimization by the compiler, because then I just don't follow the rules of React. So in that case, the compiler wouldn't work. Yeah. So keep it in mind. Don't do that, and wait for the hotfix of the ESLint plugin for that case. So it is great to know about this one. Yeah. React compiler skipped optimization this component because one or more React ESLint rules were disabled. Yeah, it's so important. So in that case, it will skip it, and you have not auto-memoized component in that case. So let's move back to errors. And here it's just what? No issue here, but in other components it could be. So it's just my note. And here it could be, there could be the warning by React that there is nothing to memoize by React compiler. So in that case, use no memo wouldn't be applied. So it's redundant here. So in that case, there should be the issue, but there is a bug. If I comment all of the rest of code, it works magically. So there is bug. So please keep it in mind. They have to fix it. It's hidden bug because of probably all other, the other rules, beat it somehow. I don't know. Great. I'm showing you this kind of example about the child rendering and parent. So I'll show you just the example, not the compiled code, but the example. That one, that state is handled here and stored here in the parent, and in the child component, there is a button with the update value function, and it's called when I'm clicking on the button and updating the state. These two components are auto-memoized. Without the compiler, we had to solve it, as I show you in the slides. And that way, wrapping use callback on the function update value, and wrap the child component with React memo, like here, So with compiler, we don't need it anymore. So great. Okay, I have to zoom it out a little bit. So there are two very similar components or base components, root components, products and memoized products. You can see here there are some lists of components, and the tree is very simple. Product example, products, and there is heading form, and two product lists. The first one is all products, and the second one is the same component, but with some flag that are future products used there. And also each component has, as an output, the timestamp of the rendering, yeah, to show you when it has changed during the rendering. So I can change the heading, and you can see just this component has changed the date time. But the first one, you know, the heading and heading form and even products are being rendered, but only on the heading, the date time has changed. How come? What? Because with the manual memoization here, I did it here old-fashioned way with manual memoization, so it means wrapping all of the components with React Memo and memoize all the stuff like use callback and use memo if it was needed in that case. And it works the same, but you can see date time has changed in all the three components that has changed, that have changed during the changing my state. So I will show you why. There is a heading component that just prints out heading, total products, and the span with date now, yeah? And it is great example to show you the compile code. So again, returns T2 variable, and T2 is just, again, the components themselves, nav, inside nested heading, and total products, and T1. What? T1. What is T1? Also, they are, you know, being recalculated when heading and total products has changed, but not T1. Yeah, and T1 it's that span with date now. So because of that, it stayed untouched and unchanged when I was rendering the other components. So it works a little bit different than manual memoization, yeah? Maybe even better. Okay, and last example here is more practical. It's just the preview here. It just, you know, it's just basic search, yeah? Fetching the data from the API and based on the field. Nothing special, but what is more important here, there is the input, yeah, controlled input, holding the data in use state, and in use effect, there is calling of get data function, and this is somewhere in my custom use API hook. And here though, yeah, there are not handled errors, sorry for that, but it's just basically fetching the response, fetching the API, return JSON, blah, 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 and return this one, the object from the hook. And I'll show you the compiled code of the hook only. Great. And this is important. T2, and T2 is this object. Loading data, get data, set data. And it's auto-memoized, so we don't have to wrap our output from, or our functions exported from the hooks with use callback anymore. It's great. Yeah, again, it has changed, or it will change, you know, if loading and data are being changed again, and here is the get data and so on, checking if it is in cache, otherwise it will be recalculated again. So the same mechanism. And I found the bug during the trying the compiler, and I have I had the same situation like here, and without use memo, I had to wrap this one. Use no memo, I have to wrap this one with use callback, otherwise it will trigger the infinite loop, yeah, because there is changing of the state from false to true for the loader, and then fetch the response, and then set it again back, and it will lead the infinite loop without use callback. So it is it is important to know about that, that it will solve for you. But during my testing, I tried it on a very similar hook in different project, and it didn't handle it because it was nested somewhere, and it didn't work. So if you try it in your projects, maybe you have to do it manually still for some cases, but it was just only one case during my testing, yeah? And I will show you some facts in the slides, because I have 10 minutes, so okay, I hope we will do it. So React version compatibility, I told that it's standalone, so you can use the compiler even with React 17. Yeah, it's great with React 17 and React 18, but you have to install this React compiler runtime package to your project. Yeah, it's for Babel plugin. And just set the target of the compile code in the Babel config. So for example, here with React 18. So I tried to make some benchmark, and I tried on Vite dev stack, and in this demo project there are 11 auto-memoized components. Thanks to compiler, there's my side gig project courses, and yeah, there were 6 auto-memoized components, but used multiple times in the app. And here's the table comparing the bundle size affecting. So it's great to know about. With React 18, it's 154 kilobytes and 158, so plus 4 kilobytes with compiler. So it will increase the bundle size. But what is even more strange that there is a huge difference between React 19 and 18 without compiler. So what? More than 30 kilobytes, almost 40. So it's crazy. And with compiler, under 4 more kilobytes. And the course is up the similar situation. It will increase 2 kilobytes more with the compiler. And even huge difference between React 19 and 18. So various apps, but these apps are hobbies apps, just not production code. But I tried it on our micro frontends in Heureka. And I tried it on homepage, and there are 7 auto-memoized components, navigation 5 auto-memoized components, again, used multiple times in the app. And product compare, where it's based on Next.js, and there are 10 auto-memoized components in the code base. And I tried to perform the benchmark bundle size affecting with Vite dev stack, and we can see because there is server-side rendering, it's not Next.js, it's custom stack. So React 18, there is some size. I want to public that, but it's a C variable, yeah? And with React compiler, it increases by 1.2%, the bundle size. And with React 19, it's it's about 20% more. Again, WAP. And with React 19 with compiler, yeah, plus 1% more, yeah? And server-side rendering, it's even stranger that it's S, and with compiler it's about 20% more, but it is the same bundle size in React 19 and React 18 and 19. And again with compiler, plus 19%. And Next.js, then you know that with Next.js 15, you can enable the compiler as experimental feature, but I did it on 14 by, setting the Babel plugin, and it has increased the bundle size by 2.5%. It's just client side. And here, though, is the output. Our homepage, and you can see the badges of the auto-memoized components. This is the proof. Yeah, I did it. And I tried to, measure somehow the performance of the memoization. So I used the React profiler, the package, the component from the React package, directly in our navigation micro frontend in Heureka with mock data, yeah, to ensure that the data wouldn't affect the performance, yeah? So there are mock data for that. And yeah, benchmarks on production code. So just for explanation, actual duration is the time spent during the rendering the profiler and its subtree for the current update, so actual time. Base duration is the estimated time, yeah, without memoization of the rendering the tree. And start time is just timestamp, as a timestamp for that where React started the current update, and the commit time is when it has changed, or when the current update has ended, you know. And you can see I tried it on 20 attempts. So I write dummy script that just, you know, rerun the application and print it out to the console, and then I had to copy that and ask ChatGPT for make it a table from me and try to calculate the average in milliseconds for me. But every my try with ChatGPT was the different result. So I had to calculate it by myself in Excel, unfortunately. And you can see here in the table that React compiler has better actual duration than without the compiler. Base duration is just the estimate, so it's not important for us. And start time is even about 200 milliseconds earlier with compiler than without. So it's better. And there are the deltas here between start time and commit time. It's just very important that compiler, in the compiler way, it took longer, about 5 milliseconds, but it had started earlier by almost 200 milliseconds. So it's better with 200 milliseconds, a lot of time, you know. And update, because the compiler aims to updates and memoization is it's very important during the updating the components, not the initial mount of the application. So have you seen the video? No? So I tried to just measure this interaction, this update, yeah, on Heureka's micro frontend. Okay. And this is the update, the average again. With compiler, it's about 16 milliseconds. So all of these metrics, again, are better with the compiler than without compiler. And again, there's calculated deltas, the differences between them, and again, 20 attempts. And you can see here that even the difference between the start time and commit time is better with compiler. And it's better and faster, about 200 milliseconds then, yeah? It has started earlier and finished it earlier. But remember this one, compiler versus manual memoization. I measured it too, the performance effect. And here though, you can see that manual memoization, it's better, but the deltas are very small. Very small. It's about, I don't know how to say it, few chunks of milliseconds for that. And even the deltas between start time and commit time are very small. And even for updates here, it's almost nothing. So maybe you have to still need the manual memoization stuff. It could have better performance for applications, but do it only if you have performance issues. And I think you can focus more on your code. So for example, there is a rollout in Meta, and there's very, very amazing numbers and facts that Meta has deployed or roll out the profiler to Questor, Instagram, Facebook, and even on Threads on production. And they made a statistical analysis of the impact of the manual memoization on productivity. So before the rollout, they had about 8% of manual memoized components in the code base. And this pull request took about 31 to 46% longer than without. And you know that compiler ensures that all code is memoized by default, so these numbers will be much higher than this table. And it means we are saving time and it costs saving money, yeah? So we can focus on production code and not memoizing stuff, because you saw the numbers and they are great. And I will be ending. Unasked questions, does it remove the dead code? Yes, it does. Can we use it in production? I think, yeah, it's possible, but probably not recommended, but it's up to you. But it is still in development, but you have to use ESLint plugin React compiler now, because yeah, it's stable. There are a few bugs, we know about it, but it's okay to use it right now. And can we forget these kind of use memo, use callback, and React memo functions about manual memoization? Yes, we can, but in future, yeah. Common takeaways from this talk. It needs some extra time. It's still in development. We should still know how did manual memoization work, at least. We have to write the compatible code for the React compiler following the rules of React and React hooks. And in the future, it will change the way of designing React apps, definitely. If you have some issues, troubleshooting is use no memo directive. I've shown you. And there are a few ESLint bugs I've shown you too. So we know about increasing the bundle size, about few kilobytes, but it's still okay. And the performance is similar or even better in some cases, or multiple cases and more cases in majority. So let's try it. Let me know about your experience. Here are the final slides about the sources. And thank you so much. Here's my LinkedIn. I will appreciate your connection in the future. So thank you so much. And the stage is yours. Thank you.